Welcome to my channel, DNA.12 Education. Hello students, welcome again to my channel DNA.12 Education. Today we are going to continue the last material about angle at center and circumference part 2. Mathematics series, angle at center and circumference part 2 for IGCSE and IB. Okay students, we go to our topic and then we're going to discuss several questions at the end of this video. But for the first, we're going to talk about angle at circumference. The first point as a pointers of angle at circumference. The first is angle at circumference as the first point. Okay, so let's look at this diagram. Let's say the circle, we name circle with center O. Okay, so then we call this one angle A degrees. This one is angle A degrees 2. And this one we call A degrees as well. Okay, and we have angle AKB, angle ALB, and angle AMB. Okay, students, angle AKB opposite to arc AB. Once again, angle AKB opposite to arc AB. Angle ALB opposite to arc AB. Angle ALB opposite to arc AB. And then angle AMB opposite to arc AB. Angle AMB opposite to arc AB. Is it right? Look at this arc. Okay. For three angles covered by arc AB. Once again, for three angles are covered by arc AB. Again, we call this one arc AB, right? So it means we can take the conclusion that angle AKB, angle ALB, and angle AMB are angle at circumference, right? So angle AKB equal to angle ALB equal to angle AMB equal A degrees. Angle AKB equals to angle ALB equals to angle AMB equal A degrees. This is the first pointers. Is it clear to you, everyone? Good. Okay, we go to angle at circumference to the second pointers. Okay, look at the diagram. This is a circle. Yeah. Okay, it has four angles. A degrees, B degrees, C degrees, and D degrees, where O lies on among A, B, C, D degrees. The second pointer is in a circle, all angles at circumference. Once again, in a circle, all angles at circumference, which is point O as a center for all angles at circumference. This is the condition. Point O as a center of all angles at circumference. Students, once again, I want to emphasize that angle A degrees, B degrees, C degrees, and D degrees lie on circumference. Okay, we have the second pointers. A degrees plus C degrees equal 180 degrees. Okay, look at this diagram. A degrees is opposite to C degrees, right? Next, the next pointer is B degrees plus D degrees equal 180 degrees. Look at this diagram. Okay, D degrees is opposite to B degrees. Okay, as we know that ABCD is a equilateral shape. Is it right? Yes. This is a polygon, right? Correct. The shape ABCD is polygon. ABCD is a polygon with four sides. It will satisfy sum of interior angle in a shape is n minus 2 times 180 degrees. Means because it has four sides, 4 minus 2 in bracket times 180 degrees equals 360 degrees. So the conclusion is A degrees plus B degrees plus C degrees plus D degrees equals to 360 degrees. Is it clear to everyone? Good. Okay, students, we go to the next pointers. Angle at circumference 3. The third pointers. We call this one angle D degrees, angle A degrees, angle B degrees, and angle C degrees. In a circle, combination of angles at circumference and angle at center. Friends, give attention fully that not all angles covered by angle at center, right? Is it clear to everyone? Once again, not all angles are covered by O as an angle at center. So what is the meaning? A degrees plus C degrees is not 180 degrees. Once again, A degrees plus C degrees is not 180 degrees. And B degrees plus D degrees is not 180 degrees. Why? This is the combination of angles at circumference and angle at center. Center O is not covered by O angles, right? So once again, A degrees plus C degrees is not 180 degrees. And B degrees plus D degrees is not 180 degrees. Okay, we agree that this shape ABOD, the shape ABOD is a polygon, a quadrilateral shape, right? ABOD is a polygon with four sides. Sum of interior angle in a shape is n minus 2 times 180 degrees. So, because it has four sides, means 4 minus 2 times 180 degrees means 360 degrees. So this shape satisfies A degrees plus B degrees plus C degrees plus D degrees equal 360 degrees. Is it clear to everyone? This is the combination of angles at circumference and angle at center. But as we know, angle at circumference is a half of angle at center, or angle at center is twice of the angle at circumference. Can we apply it here? Of course. Okay, go to the next pointers. Angle at circumference and tangent line. This is the 4 pointers. What is tangent line? Okay, we'll discuss it later. Students, let's say this one is D degrees, A degrees, and then this one is angle at center. Yeah, let's say B degrees, and this one is C degrees. Okay, there are 2 tangent lines. They are line CD and line BD. CD and BD lines are tangent lines. And both tangent lines are covered by M degrees as intersection at the point D, right? So tangent line CD and BD intersected at point D and covered by M degrees. We call this one tangent line. And here is tangent line, right? So point B and point C are tangent point. Once again, point B and point C are tangent points. What is tangent line? Tangent line is a line perpendicular to radius. Okay, I want to give you simulation how to draw the tangent line. Okay, so then this is the tangent line. Look at the diagram. One. Okay, perpendicular to radius. Is it clear to you? And this one here at point C, tangent line, perpendicular to center or radius. So when we find the tangent point, means we will find the tangent line means there is 90 degrees. So at point B, there is 90 degrees angle. And also at point C, we will find 90 degrees also. Is it clear to you? Very good. Okay, students. Okay, we call this one arc angle. We call this one is arc angle AC. Arc angle equals to angle at center. Let's say this one is X degrees. So X degrees equal to angle AOC. AOC as an angle at a center. Okay, once again, I want to emphasize and to remind you everyone, arc angle equals to angle at center. This is the angle, right? This one. Arc angle equal angle at center. So X degrees equal angle AOC. And C degrees is angle at circumference. Right? So C degrees is a half of X degrees is a half of B degrees. Clear to you, everyone? A half of p degrees. Next, okay, we call this one arc angle as well. Arc angle AD. Arc angle AD is equal to angle at center AOB. Okay, look at the diagram. Arc angle AB equals to angle AOB as angle at center. Is it clear to you? So when we construct the angle ACB, this one, right, we'll find angle at circumference. Okay, arc angle, we name this arc angle is y degrees. So means y degrees equal to angle AOB, means a degrees is a half of y degrees. Next, so what about this one? Arc angle BC. Arc angle BC equals to angle COB. Let's say this one is z degrees. So z degrees equal to angle COB means d degrees equal a half z degrees. Okay, look at the simulation, this one. COB equals to angle z degrees or arc angle BC. And we got angle at circumference covered by d degrees. So it means d degrees equal a half z degrees. Is it clear to you, everyone? Okay, good. So what is the next pointers? Okay, let's say this one is n degrees. This one is n degrees, right? Okay, n degrees plus b degrees equal to 360 degrees. Okay, b degrees is reflex of n degrees, right? So we can find m degrees as intersection of CD and BD lines. M degrees equals a half, open the bracket, b degrees minus n degrees. Once again, m degrees is half times, open the bracket, b degrees minus n degrees. Is it clear to everyone? Listen, x degrees, y degrees, z degrees are arc angle or angle at center. Okay, students, to make sure everything's clear about this material, we go to several examples to do. Example 1. We call this one is d degrees, a degrees, 132 degrees, and 64 degrees. Find angle angle ABC, angle BAO? Yes, only two questions. Find angle ABC and angle BAO. Students, BCOA is quadrilateral. So it means it is a polygon, right? Students, angle ABC is opposite to arc major AB. Is it clear to you? Once again, angle ABC is opposite to arc major AB. This one, major AB, right? Is it clear to you, everyone? Angle ABC is opposite to arc major AB. Okay. So it means D degrees is opposite to the reflex 132 degrees. Is it right, everyone? Means D degrees is angle at circumference and reflex to 132 degrees is angle at center. Which one the reflection angle? This is the reflection angle. 360 degrees minus 132 degrees. Equals to 228 degrees. So 228 degrees is angle at center and D degrees is angle at circumference. Look at the measure AB, right? Next, angle at center AOC is 360 degrees minus 132. We got 228 degrees as a reflex angle, right? Angle D degrees is angle at circumference of angle at center AOC. Means D degrees is a half time 228 degrees. We got 114 degrees. Very easy, right? ABCO is a polygon with four sides. It satisfies the formula that A degrees plus D degrees plus 64 degrees plus 132 degrees equal 360 degrees. Do you remember the concept? Yes. D degrees plus 132 degrees is not equal to 180 degrees, right? And A degrees plus 64 degrees is not equal to 180 degrees. Remember the concept. This is the combination of angle at circumference and angle at center. Cannot satisfy, right? So D degrees plus 132 degrees is not 180. And A degrees plus 64 degrees is not 180 degrees. Is it clear to everyone? Okay, next. Now we're going to complete the data. 8 degrees plus 114 degrees plus 64 degrees plus 132 degrees equals 360 degrees. So it means 8 degrees is 50 degrees. Very easy, right? Very good. Okay, students, we go to the next example. This is the second example. Okay, students, this is very easy. The points A, B, C, D, and E lie on the circle. PAQ is a tangent to the circle at A and EC equal EB. Angle ECB is 80 degrees and angle AB is 40 degrees. Find the values of B, W, X, Y, and Z. This question is very easy, right? Okay, students, we go to the solutions. Are you ready? Okay. Okay, once again, look at the slow motion. Okay, once again. Okay, next. Okay. So what's the conclusion? That's right. Angle EBA or angle ABE opposite to arc AE. Angle ABE opposite to angle arc AE. And angle PAE is opposite to arc AE as well. Angle EBA, angle EAP, and angle EDA opposite to the same arc. The arc is AE. Because they have the same arc, so means P degrees equal 40 degrees. Same, right? So what about angle EDA? Once again, angle EDA or angle ADE, same. Angle ADE opposite to the same arc. The arc is AE as well. Once again, there's a simulation, right? Angle ADE opposite to the same arc. The arc is AE. So means what's the conclusion? That's right. So X degrees is 40 degrees as well. Very easy, right? Next, look at the triangle BEC. Okay? BEC is isosceles, right? How do you know that the information isosceles? We got the information from the question. EC equal to EB. So, EC equals to EB. Isosceles. So, automatically, W degrees is 80 degrees. Right? So, angle BEC equals 180 minus, open the bracket, 80 degrees plus 80 degrees. So, means we got angle BEC is 20 degrees. Right? Next. Okay, so let's now look at the quadrilateral ABCE. ABCE. In a circle, y degrees plus 80 degrees equal 180 degrees. So means y degrees is 100 degrees. Okay, look at the slow motion. Okay, once again, quadrilateral. Is it right? Quadrilateral. It satisfies the second pointers, right? What does it mean? Y degrees opposite to 80 degrees. Y degrees opposite to 80 degrees. So that's why y degrees plus 1 or y degrees plus 80 degrees equal 180 degrees. Once again, y degrees plus 80 degrees equal 180 degrees. So y degrees is 100 degrees. Is it right? Good. Students, angle E, A, B, and C are angle at circumference, right? Next. Okay, good. Okay, students, we go to the next question. At the same question, right? We're going to finish it. Look at the quadrilateral ABCD. ABCD. Okay, once again. Look at the dotted line. Is it clear to you, everyone? Okay, so what's the pointers? That's right. Z degrees opposite to 40 degrees plus W degrees. As we know that Z degrees plus, open the bracket, 40 degrees plus W degrees equal 100 degrees. Once again, Z degrees plus, open the bracket, 40 degrees plus W degrees equal 180 degrees. As we know that W degrees is 80 degrees. So Z degrees plus, open the bracket, 40 degrees plus 80 degrees equal 180 degrees. So automatically, we'll find that Z degrees is 60 degrees. Very easy, right? Okay, students, we go to the next example. Example 3. In the diagram, K, L, and M lie on the circle, center O. Angle KML is 2x degrees. KML is 2x degrees. Okay, I will show you this one, right? KML, 2x, this one. Right. And reflex angle KOL is 11x. KOL, reflection of KOL is 11x degrees. This is the reflection, right? I will show you this is the reflection. Okay. The reflection angle KOL is 11x. 11x. This is the reflection of KOL, 11x. Yeah, right? Automatically, here is this one, 360 degrees minus 11x degrees, right? Is it clear to you? For the reflection, sum up of both angles or sum up of the both angle is 360 degrees. That's the reflection angle. Okay, students, go. Find the value of x. Angle at center is twice of the angle at circumference, right? Only this one. Concept very simple, right? Angle center is 360 degrees minus 11x degrees. Means twice of the angle at circumference. Angle KML is angle at circumference, right? Okay, so 360 degrees minus 11x degrees equal 4x degrees. So 360 degrees equals 50x degrees. Automatically, we found x degrees is 24 degrees. So easy, right? Good. Okay, so next we go to example 4. Example 4. The diagonals of the cyclic quadrilateral ABCD intersect at X. Number 1, explain why triangle ADX is similar to triangle BCX. Give a reason for each statement you make. Number 2, AD is 10 cm, BC is 8 cm, BX is 5 cm, and CX 7 cm. Calculate DX and calculate angle BXC. Okay, students, we are going to answer this one step by step. Question 1. Explain why triangle ADX is similar to triangle BCX. Okay, students, we're going to try to answer this one. Okay, this is the answer. Okay, look at the slow motion. Okay. So what's the conclusion? Yes. Angle ADX opposite to arc AD. And angle ACB or XCB is opposite to arc AB as well. Let's say this one is gamma. Automatically, here is gamma as well, right? Why? Because they have the same arc. The arc is AB. Right? So angle ADB is gamma and angle ACB is gamma. They have the same arc, AB. So angle ADB and angle ACB are angle at circumference with the same arc AB. Angle ADX equal angle BCX means same segment or same arc. And angle DAX equals to angle CBX means this one. Right? Angle DAX equals to angle CBX. Okay? Let's say angle DAX is alpha. Automatically, angle CBX is alpha as well. Right? They have the same segment. The segment is BC, or they have the same arc. The arc is BC. Is it right? So the conclusion is angle AXD equals to angle BXC. Angle AXD equals to angle BXC. We name the angle is theta. So theta equals theta. Angle AXD equals to angle BXC. So the conclusion is triangle ADX is similar to triangle BCX. Is it clear, everyone? Next, okay, we go to question 2. AD is 10 centimeter, BC is 8 centimeter, okay, BX is 5 and CX 7. AD is 10. BC is 8. BX is 5. And CX is 7. So, because both triangles are similar, you can say that BC over AD equal CX over DX. Once again, BC over AD equals CX over DX. Now, you have to insert the data and length, of course. A over 10 equals 7 over dx. And then by using cross multiplication, we got dx is 8.75 centimeter. Very easy, right? Now is calculate angle BXC. Calculate angle BXC means we have to use cosine rule. Okay. Okay. Why have to use the cosine rule? Look at this diagram. Okay, that's very simple, right? How to use the cosine rule. Look at this triangle. Very easy, right? Look at the triangle BCX or BXC. Same, right? Cosine rule is BC square equals CX square plus BX square minus 2 times CX times BX cosine theta. So x square equals 7 square plus 5 square minus 2 times 7 times 5 cosine theta. You remember this cosine rule? Of course, right? Go. 64 equals 49 plus 25 minus 70 cosine theta. 70 cosine theta equals 10. By using calculator, use your scientific calculator, theta is 81.78 degrees. Very easy, right? Okay, students, we go to the next example. Example 5, of course. Okay. Let's say this one is d degrees. This one is 8 degrees, and this one is 224 degrees, and this one is 8 degrees. And there are two tangent lines. The line is line ED and line FD are tangent lines. And line ED and line FD intersected on point D and covered by m degrees. Okay, we call this one is tangent line, and this one is tangent line as well. So point B and C are tangent point. You still remember about tangent? That's right. The line will be perpendicular to the radius, right? Lines ED and FD are tangent lines. Our angle AC is 88 degrees. Our angle AB is 136 degrees. Angle ECA is 42 degrees. Find A degrees, C degrees, D degrees, and degrees, M degrees, and angle BCD. Okay, let's start answering this question, everyone. Okay, we call this one arc angle AC. Arc angle AC. Okay. 88 degrees. As I mentioned before, arc angle equals to angle at center. Sorry, once again, arc angle equals to angle at center. Okay, we have to construct number one. Okay, understand? And angle at circumference, this one, right? This is the angle at circumference respect to 88 degrees. Is it clear to everyone? Is it clear to you? Good. Okay, now we go to the next. So what is the information? The information is angle AOC is 88 degrees, right? Angle AOC equals to arc angle is 88 degrees. So this one is 88 degrees. So automatically we'll find C degrees is 44 degrees. Is it clear to you, everyone? Okay, next. X degrees equal angle AOC. So C degrees is a half of X degrees. So C degrees is 44 degrees. Is it clear to everyone? Good. Next, arc angle AB is 136 degrees. This is the diagram. Okay. Arc angle AB equals to angle at center AOB. Right? And of course, angle at circumference is 1. Is it clear to everyone? So, means you're going to find the information here, this one, everyone. Arc angle is 136 degrees. Right? So, arc angle AB equals to angle at center AOB, 136 degrees. So automatically A is a half of 136 degrees. Right? So A degrees is 68 degrees. Right? Next. So, y degrees is angle AOB. Okay, so automatically A degrees is a half y degrees. So automatically we get A degrees is 68 degrees. Next. So how about arc angle BC? Okay, we go to the next answer. C degrees equals to angle COB and D degrees is angle at circumference. Right? Okay, this one is Z degrees. Arc angle COB. This diagram. Good. So what is the size angle of arc BC? That's very easy, right? So here is 360 degrees minus 88 degrees minus 136 degrees. As you know that one rotation is 360 degrees. Equals to 136 degrees. So we got automatically d degrees is out of a half of 136 degrees. Right? So d degrees is a half of 136 degrees. We got 68 degrees. Very easy, right? Okay, what about n degrees? Yes, n degrees and 224 degrees add up to 360 degrees because one rotation, right? So n degrees is 360 degrees minus 224 degrees. 360 degrees minus 224 degrees, we got 136 degrees. Next. So m degrees as angle by ED and FD intersection line. As an intersection line, yeah, line ED and line FD intersects on point B to construct m degrees. Very easy, right? Okay, we can find m degrees. Okay, m degrees equal a half, open the bracket, b degrees. Which one b degrees here? B degrees is 224 degrees. Actually, this one. Yeah, one. 224 degrees minus n degrees. 136 degrees. Equal we got m degrees is 44 degrees. Very easy, right? So m degrees is half of 224 degrees minus n degrees. So half, open the bracket, 224 degrees minus 136 degrees. We got m degrees is 44 degrees. Is it clear to you, everyone? Okay, very good. Okay, students, to make sure everything's clear about this material, so I'll give you several questions as exercises. Exercise for you. Good luck.